All right, I'm gonna do quite a few of these examples, just so both third and seventh period, both of you guys have a decent amount of these examples recorded. So we are doing the derivative of y with respect to x, or finding the first derivative for this equation. I can tell right away by looking that I'm going to have to use implicit differentiation because it's not a y equals, okay? It's not a y equals, and solving for y, not impossible, but why waste our time? Let's just derive implicitly. I also see right here that I'm going to have to use a product rule because I have x times y. So I'm going to have to use product rule there, 1d2 plus 2d1. So let's start with that product rule. 1d2 plus 2 d1. So it was the first, which is x, times derivative of the second, which is dy dx, plus the second, which is y, times derivative of the first, which is 1, plus the derivative of that guy, which is dy dx, and that's equal to 0, because derivative of 9 is 0. Now our job, now that we've derived implicitly, check, our job is to isolate dy dx. So let's do that. We have, let me just make this pretty, x dy dx plus y plus dy dx is equal to 0. So right now we're going to just do some algebra. I'm going to go ahead and move this y over here. So x dy dx plus dy dx is equal to negative y. I'm going to factor out a dy dx. So dy dx times x plus 1 is equal to negative y. dy dx is equal to negative y over x plus 1. There's our first derivative of that equation. And we need to find dy dx for that equation at 2, 3. So at that point, 2 goes in for x, 3 goes in for y, and you will find the slope of the tangent line of this function at 2, 3. In number 3, we also have a pretty messy little problem here. Still implicit because it's not solved for y, and it's going to be very, very almost impossible to do so. And I see product rule right here, product rule right here. So it's just a matter of staying organized. So we've got, I'm going to make a bracket for the first product rule plus a bracket for the second product rule. Let's put my equal sign. And let's go slowly. Remember that's 1, 2, 1, 2. So 1 d2 plus 2 d1, 2d1, all right. Over here, 1 d2. Notice how I'm putting the dy dx. So it's 2y dy dx, because when we're doing implicit differentiation, every time you derive y, dy dx. So 1 d2 plus 2 d1 equal to derivative of 2x. Now that we've derived implicitly, let's just clean this up and isolate dy dx. So plus 2xy plus 2xy dy dx plus y squared equals 2. We cannot combine these because they're not like terms. That has 2xy dy dx. So if our job is to isolate this guy, we got to get rid of him and him. So let's subtract them over. So x squared dy dx plus, leaving this one over here, 2xy dy dx. And we're going to move these guys, subtract those guys over. So that's equal to 2 minus 2xy minus y squared. Getting these over here so that we can start the process of isolating. And just like the last question, factor out a dy dx, divide by x squared plus 2xy. And that will give you your pretty decent sized derivative. And then we need to find it at 1, 1. Okay, for this next one, we're still deriving implicitly. Obviously, this is the implicit section. I see a chain rule here, so let's go slow here. So 2 times x plus y, now raised to the first, times the derivative of what's inside, which is, it's a sum, so 1 plus dy dx. Okay, so d outer, which is 2 x plus y, I'm sorry, to the first, multiplied by d stuff, which is 1 plus dy dx, plus the derivative of y, which is dy dx, equal to 0. So again, we did a chain rule using implicit differentiation. And now we have to isolate dy dx. So the algebra here could get a little tricky. Let's see, how do we want to do this? What's the easiest way? Should we distribute? Let's see, I haven't done this problem, so let's distribute. Let's distribute 2x plus 2y, oh, that's a y, multiply that by 1 plus dy dx, plus dy dx, that's equal to 0. Should we FOIL that out? Let's FOIL this out right here. Looks like we may have to FOIL. I don't know how else to unlock it, and we got to FOIL. So 2x plus 2x dy dx. So first, outer, inner, and last. Okay, there we go. That's equal to 0. And then, yeah, that's the way to do it. We had to FOIL that, and I know it seems counterproductive, but now that we've FOILed that, we can move this one over here, we can move this one over here, and then we can take out the GCF of dy dx. So I'm going to go ahead and do that all in one swoop. We've got negative 2x and minus 2y on the right. We're going to take out a dy dx, leaving us with 2x for this one, plus 2y for that one, plus 1 for that one. Should be able to put that back in, and then divide by this on both sides. And you have dy dx. For the trig function on number 8, this is trig on the left here. It's just tangent, and here's my angle. So d trig, so secant squared x plus y, times the angle, which is 1 plus dy dx, is equal to 1, which is the derivative of x. We are trying to isolate dy dx, so let's divide by secant squared x plus y, and then subtract the 1. So I'll do that in 2 steps. So 1 plus dy dx is equal to 1 over secant squared x plus y, and minus 1, minus 1. So there's dy dx, and it didn't ask us to evaluate. That's it.